Hi, and welcome back. On the last video, we solved this example, the example 2.8, which is about combined transformations. So this example gives to us a point and is represented that way with this notation, and it says that this point is linked on the referential F and OA, and this point will will pass for these combined transformations. The first one was a 90 degrees above the axis Z. The second, followed by the second one, which is a also a rotation transformation of 90 degrees around above the axis Y. And the last transformation is a translation transformation with these coordinates. And the example asks to us to find the coordinates of this point in relation to the reference system after these transformations. So as we have been studying, we already know what is a pure rotation, and we have these characteristic matrices, and knowing this we know how to solve this example. And we also study uh, these notations. So this notation means that we are able to track this point, which is this referential system F and O is linked on this fixed reference system Fxyz, and the reference system FNOA, or sorry, FAO, is the reference system that we call a derivative reference system. So we link this on the region of a other reference system, and this way we can write uh, the position, the rotation of a point of a rigid body reference to this other one, and it tells to us that uh, it's being done a rotation transformation above the axis X with some theta angle, and we draw the transformations. And I said that on this video we will solve other example, and on this example you will see that is the same point. We are dealing with the same situation, but right now the order of the transformations, they will change. We are first applying a, a rotation of 90 degrees above the axis Z, followed by a translation. So notice that now we are changing the order of the transformations. Is the same point, but right here we apply two rotation transformations, and the last one is the translation. But on this example that we are about to solve, uh, the order of the transformations uh, we change, and you will see that this change the whole scenario of the final orientation position that we got is totally different. Okay, so let's solve this. This time I'm gonna try to illustrate better what happens when we are dealing with the transformations above the axis. So I'm gonna try to, to draw with more details. So let's draw the reference system Fxyz. So we have the axis Z, the axis X, and the axis Y. And as we have been done all this time, uh, we've got other reference system, and the ref system FOA, which also call it the rotational reference system. In this axis or unit vector is A, this one is N, and this other is O, and is linked the reference system Fxyz this way. And the first transformation is a rotation of 90 degrees above the axis Z. So I'm gonna pass a line above the axis A or unit vector, and applying the rotation of 90 degrees. So it's important also to know what is the characteristic matrix of this transformation of rotation, which is this one. So let me copy and paste right here because we're gonna use. And if we rotate this reference system 90 degrees, the this axis, this unit vector n is going to tend for this direction, and this unit vector O, it will also change, and it will look this way. So before the transformation, and after the first transformation, after the first transformation. After let's use this notation. Rotation after rotate above the Xz 90 degrees. And the second transformation, now the order of the transformation change in relation to the example 2.8. And what I wanted to show you is how this is going to influence on the final orientation and position of this point. So now applying a transformation of translation. Draw this going to be a bit tricky, but if you followed, you also going to be able to draw and translation is it can be messed to draw. So let me erase this. What going to happen is that now this reference system FNOA is going to change in terms of position. Let me see the way that I'm going to do this. Okay. So now let me copy the coordinates of the translation. So it's changing 4 units for X, -3 for Y, and 7 units for Z. So 1, 2, 3, 4, and we'll translate 1, 2, 3, 4, and -3, 4, -3, 4 for Y, 1, 2, 3, -3, right here is 4, and 7 for the axis Z. 1, 2, 3, 4, 5, 6, 7, and we place the reference system right here. And that is the final position of the point. Oh no, sorry. We got the last one, which is the also a 90 degrees, but now above the axis Y. But at this point, you already can see that is pretty different from the way that it looks on the example 2.8. Just by changing the order of the transformations, this will change the whole orientation and position of the point. So this example 2.9 complements the example 2.8, and it gives us a sense of what a transformation can do on a rigid body on a point. And now applying that is the after the second transformation. After translate 4 minus 3 and 7 units. And now applying the last transformation 90 degrees above the axis Y. So let me copy this again. Let me So if we have to rotate above the axis Y, I'm gonna copy this axis. Let's place the axis Y right here. So imagine that the axis Y now is right here, and if we rotate 90 degrees, but as this axis is Y, and hope you can see that what's gonna happen right here. So I'm gonna need space right here. Let me got some space to do the transformation. let me try and rotate this whole structure 90 degrees. And what's going to happen is that the axis O is going to be point to on the same direction as the axis Z. This way, the axis A is going point on the same direction as the axis X, and N is going to point on the same direction as the axis Y, this way, and it will look this way after the last transformation, which is a rotation above the axis Y. So look, the difference of the position of the point is right here, and on the example 2.8, the position of the point ends right here. And just by changing the order of the transformations, the scenario changes completely. And the example 2.8 and 2.9 is to give us this sense of how a transformation can affect the position and orientation of a point and a rigid body. Okay, the next video we will start talking about, we will keep talking about transformations, but this whole time we have been talking about transformation based on a fixed referential, but now we will talk about the transformations, um, how they can be done, but now with a rotative referential. So this whole time we have been talking about transformations, but a fixed referential. And on the next video we'll talk about a transformations, but now rotative referentials. And that's it. Uh, see you on the next video. Bye bye.